Alrighty, so for chapter 9, we're doing our video on mathematical induction, which is on section 4. And you want to use mathematical induction to prove the formula for every positive integer. So what does that mean? Well, you want to make sure that every single integer, so 0, 1, 2, all those can plug into the formula and it'll come out as true. And so the way you do it is you start off by getting this series. So in this case, it starts with 2, 4, 6, and 8. And then you come up to the end, which is the formula part. And that's 2n is equal to n times n plus 1. And so for mathematical induction, the way you want to solve is by using a 3-step process. And the first step within that 3-step process is showing that s of 1 is true. And so this is a fairly easy step. Really, all you have to do is plug in 1 where n is. So you take the latter part of the formula, which is 2n, right there at the end, and you're going to plug in 1 instead of n. And so if you come out with the very first term in the series, so in this case it's 2, you can see that 2 is equal to 2. So there's our first step right there. We showed that s of 1 is true, and we can go on with our 3-step mathematical induction process. Now it's time for step 2 of mathematical induction. And this is by far the easiest step. And what you're going to want to do is assume that s of k is true. And literally the only thing you do in this step is plug in k wherever you see an n. That's it. So in this case, s of n will turn into s of k, and 2 of n will turn into 2 of k, and n times n plus 1 will turn into k times k plus 1. So very, very easy step. You just have to plug in all the k's and just leave it as is. Alrighty, so for the last step of mathematical induction, you're going to want to prove that s of k plus 1 is true. And this one's the most difficult step for most kids because it requires a lot of tracking and a lot of knowledge on which term is which. So you're going to want to set 2 sides to this equation. There's going to be a side that has s of k plus a of k plus 1, and then another side that has s of k plus 1. And so for your s of k and plus a of k plus 1, you're going to want to go ahead and match the terms. So a of k plus 1 will match with the 2n at the very top, and the s of k will match up with the n times n plus 1. But you don't want to use n's because we assumed s of k is true in the previous step, so we're going to be using k's instead. So it would be k times k plus 1 plus 2 times k plus 1. And you might be wondering, well, why isn't it 2k? Because it's 2n. Well, the step states that it's a of k plus 1, so instead of substituting just a regular k, you're going to be substituting a k plus 1. Now, for the other side, it's almost exactly the same. You're going to be going to take the k times k plus 1 side, and instead of using k's, you're going to be using k plus 1, because the step states s of k plus 1, and not just, regular old k. And now for the final stretch, you're going to want to set both sides equal to each other and start solving. So on the left side, we're going to multiply k and k plus 1 to get k squared plus k, as well as 2 times k plus 1, so we can get 2k plus 2. On the right side, we're going to go ahead and leave k plus 1 as is, but we're going to do k plus 1 plus 1, simplify that, and makes k plus 2. Now, for the right side, we're going to go ahead and FOIL k plus 1 and k plus 2, which gets us k squared plus 3k plus 2. And so that's the right side finished. And then on the left side, we're going to combine like terms, and we get k squared plus 3k plus 2. And would you look at that, they're both equal to each other, and that proves that our mathematical induction was successful. And that's it for this video.